All right, so welcome back to another part of the chassis tutorial CAD project, right? And as you can see on my screen, I'm not on SolidWorks, and so uh, I'm gonna show you guys some stuff that I need to tell you before we start the CADing. And as you can see on my screen, where my mouse is, it says 20 DP half-inch hex bore gears, right? And the reason why I'm showing you this is because I need to tell you guys what DP is, right? And so DP stands for diameter pitch, right? And before I even explain what diameter pitch is, let me just scroll down here and see the drawings. Yeah. So here's the drawing of a gear, and there's something called pitch diameter, right? Not diameter pitch, but pitch diameter, and that's the diameter of the imaginary circle of the gear, right? Hold on. If I were to explain this better, let's say we catted a circle that has the diameter of the pitch diameter, right? And say we wanted to mesh two gears in real life, and so we would CAD it so that there would be two circles that are that have the diameter of the pitch diameter, right? And those two circles would be tangent, right? And the reason why we're using pitch diameter instead of outer diameter or inner diameter is because pitch diameter is a diameter in which the teeth would actually mesh in real life. Notice how the diameter is like in the middle between the outer edge of each tooth and the inner, right? And so going back up to diameter pitch, there's a 20 right next to diameter pitch, and 20 is a constant. And so what diameter pitch is it's the ratio between the number of teeth the gear has to its pitch diameter. And so say this gear right here was say a 50 tooth gear, right? Using this ratio right here, 20 dp, we could just divide that by 20 to find out what the pitch diameter is, right? And so 50 over 20 would be 2.5, and we could check that over here, right? Let me scroll down to 50. 50 tooth, 2.5 inches, right? Pitch diameter. And so this is very important because if you like sketch this wrong, your whole gearbox CAD is gonna like be ruined because the gears wouldn't even mesh in the first place. So yeah, and I'll be back once I open SolidWorks. All right, so I'm on SolidWorks, and let's make a new part. And the reason why we're making a new part is because we got to make the plates for the gearbox. Hold on, let me just show you a layout of what the gearbox is going to look like before I even do anything. Let's see. It's not going to be dual speed. Hold on. Actually, hold on. Let me look for a single speed gearbox. There we go. So this is how it's going to look like. There's going to be two plates, right? One, two. And so we're going to be CADing the plates first. And then after that, you can just download all these files, right? All the gear files, all the pinion files, standoff files, motor files, CAD your own spaces and hex shaft, and put them all in assembly. I might do a video on that, I might not, but we'll see. So this is how it's going to look like. I think in the bottom there's a better view. Yeah. So there's going to be three motors, right? We're just going to CAD like a basic Vex single speed gearbox, right? So there's going to be three motors. There's these small gears right here. Connected to the motors are pinions, or yeah, they're pinions. Normally they're 12 tooth. Meshed with the pinions is the 50 tooth gear. In front of that is a 34, and meshed with the 34 is the 60 tooth gear, and you have all the bearings and stuff, right? And so we're gonna sketch, right? Choose a plane. Doesn't matter what plane you choose. And I'm gonna draw a circle right here. In this circle, I like to use this circle as my 50 tooth gear because if you go back up here, this 50 tooth sits like kind of in the center of the gearbox, and so I like to center that at the origin just to make things easy. All right. So before I even give this a dimension, I'm just gonna just quickly sketch all the other gears. And the reason why I'm doing this is because if you're doing everything all at once, you don't need to individually give each circle a specific dimension, right? That would just waste you a lot of time. If you set like a bunch of circles equal to each other, because like say you have multiple of the same component, you could just set them all equal to each other and just define one component that that you selected. So yeah, and hold on. Before, let me just undo this. So when I'm adding these circles, I'm hovering over the edge of the circle, and you can see a tangent symbol. It's pretty small, but there's a tangent symbol. Once that tangent symbol appears, just click on it. That automatically makes this circle tangent with the other circle, right? Right? No matter where I move it, it's always tangent to the other circle. All right, so I'm just gonna keep creating circles. This is the 50 tooth. These are the pinions. Now we got to create the motors, right? I mean, you don't necessarily need motors, but I'm doing this so that I can kind of like see how this plate's gonna look like, right? Now we have the 34. The 60 is gonna be tangent with the 34. Don't worry, we'll give these measurements. Now we need holes, so we have bearing holes, right? I'll undo bearing holes. And we need pinion holes. And the reason why we need pinion holes is because since the motor is going to be below the plate and the pinions are going to be on top, there's got to be some way those two need to connect. So there has to be a hole in between so that the pinions can fit in. Okay, I think that's good enough for now. And the reason I'm saying this for now is because there's extra stuff that we gotta add. But for now, this looks like pretty messy, so I'm just gonna define all this first. So we have the 3 motors. I'm gonna select all of these, and there's a make equal function, right? It should pop up. If that doesn't pop up, there's an equal command towards your left. So I'm just gonna click on that. Make all these equal. Make all the pinions equal. Make all the pinion holes equal. Try not to select everything, because if you like accidentally select everything, you gotta undo, right? And if you don't undo, everything's gonna be like over defined. You can't do anything. And I think the bearing holes need to be equal as well. All right, I think that's good. Okay, now we can start. Before that, these motors are kind of in the way, right? Because motors aren't necessarily that important. It's just to see where I can create this outer edge of the plate. So I'm just going to make this construction geometry, right? Actually, I'm going to make all the gears in construction geometry, because we only need actual solid circles for where there are actually going to be holes in, right? The whole point of CADing is to eventually CNC this plate, right? And so what the CNC does is it makes holes, right? So we only need solid circles for where it's going to make holes, right? Gears are not holes. They're just there, right? They're going to be attached to a bearing that goes inside those holes, right? So yeah, so that's why I'm making all these construction. Now I gotta fully define all of these, so I'm gonna start giving these measurements. So motors, we normally use Neo motors, right? Because that's what we use in school. And so Neo motors are 2.55 inches in diameter. I memorized it from experience. The 50 tooth gear, right? We calculated it to be 2.5. So which means we can calculate 34. If you just type in 34 divided by 20, SOLIDWORKS automatically calculates it for you, right? So if you press enter, 1.7, right? The pinions are 12 tooth, so 12 divided by 20, right? 0.6. The 60 tooth gear is going to be 3 because 60 over 20 is 3. Now the bearing holes, if you're going to memorize any measurement, you should memorize what the bearing holes are, right? Bearing holes are 1.125 inches in diameter. The pinion holes, I like to make them 0.76 because the outer diameter of the pinions themselves are like around 0.75. I mean, you can make it 0.8 if you want, just to be safe, as long as it's not way too big or way too small. Okay, so these center circles are fully defined because they're centered at the origin, but now these circles are kind of, kind of loose. Oh wait, I forgot one thing. I gotta add a bunch more circles. So these circles, right, on the Neo motors, they have like built-in screw holes so that you could like use them to attach those motors to stuff, right? So we gotta create screw holes or holes to actually put in bolts through those screw holes, right? So I'm gonna create like 2 screw holes for each Neo motor, right? And okay, I'm gonna make these circles construction because they're not actual holes. These are the holes that we only need to fully define. Okay, now these. Okay, now let's start fully defining everything. So before I fully define the screw holes, let me fully define the position of the motor. So what I just did is I pressed on line, and if you click on the drop down menu, there's something called center line. It's just a line in construction geometry. So you click on that, and I'm just gonna create like this triangle, and I like to make the motors kind of like in an equilateral triangle like form. So you just make all of these lines equal. It's still underdefined, and that's because this triangle you could like rotate it however much you want. So I'm going to make this bottom edge, hold on, I make this bottom line horizontal, right? And there we go. Now I'm going to fully define the 60 tooth gear, so I'm going to create another center line, and I'm going to make this line vertical, right? Okay, so now we got to fully define all the screw holes, so I'm going to try to make each screw hole like 180 degrees away from each other, right? Notice how this line is not connected with this center of the circle. So you could just highlight the line and the point and make them coincident. Or you can make them midpoint, it doesn't matter. But I think coincident might be better. Let me try midpoint. Okay, yeah, that doesn't make any difference. Okay. So they're still underdefined. So I'm gonna connect these right here to create some sort of like a hexagon shape, and I'm going to highlight these lines that I just made. Hold on, highlight the lines that I just made and make them all equal. Okay, it still looks a little off. Let's see. Alright, because I forgot to make these circles equal. Okay, make these equal. I'm gonna, these are 2 inches in diameter, and the circles are 3/16 in diameter because they're 1032. Oh wait, undo that. Oh, I'm dumb. You gotta select all these first and make them equal, because like you just saw, I just created a dimension for just one of those circles, right? And everything else is still underdefined, so I'm gonna make all these equal. And then I'm going to define this 3/16. Bam. Now everything is fully defined. Okay, we're still missing some stuff. Uh, so I'm going to, but first, we're going to add that. But first, I'm going to just hide these. So if you want to hide all these numbers, right, because they get in your way, you click on the drop down menu in hide show items. Click on the dimensions icon, and it's gone. And if you want to turn them back on, just do the same thing. Okay, now we're missing standoffs. Okay, and what standoffs are is, if you come here, standoffs are these little like cylinder like things that connect the two plates together, right? Um, so SOLIDWORKS. Okay, so I'm going to create standoffs in like this, and I'm going to make them tangent to one of those circles so that I don't have to like I don't have to make you know I won't have to make the circles tangent to both, because that would just take me more time. Now I'm gonna highlight all these outer circles, make them equal. Highlight all the inner circles, make them equal. The standoffs, I normally like them as 1032 holes. So 1032 is 3/16. And these, I just make them 0.6 so that the standoffs have like space. Like say the CNC like did something weird and the holes were a little bit off. This 0.6 gives that a little bit some sort of like leeway so that the standoffs still have somewhere to go, because that's really important. Okay, now I'm going to select all these outer circles and make them into construction geometry, and I'm going to make these tangent, right, to make these circles fully defined. Okay. Now all we gotta do is create the outer edge of the plate. So how we're gonna do that is, first we're gonna select a line, and it's gonna be a solid line because we can't extrude construction geometry lines and arcs. So we're gonna make it solid. So I'm gonna click on this edge of the circle. I'm gonna hover over the edge of the other circle until the tangent symbol pops out right there, right? And once you see that tangent symbol, just click on it, and the line is automatically fully defined, right? You don't need to use the tangent command, right? And make sure you don't overlap with other circles like you see here. Make sure you're doing it correctly. Okay, tangent. And I'll just fast forward this once I'm done finishing. Alright, so I'm done making all of the lines tangent. And now we got to create arcs. So click on center point arc, where my mouse is right now. Right, and we're going to click on the center and click on one endpoint. And you see like this blue outline. Make sure the outline is facing towards where you want the arc to be. And once you hover your mouse over the second endpoint, make sure the line is highlighted. If it's not highlighted, it's not going to close the line. So just click on that once the line's highlighted, and repeat that, right, until your arc is finished. So I'm going to fast forward this. Okay, so now that we have the outer edge, right, all we do now is just features, extrude this, click on it, and we're gonna make it a 1/4 inch thick. and press check. Okay, so we have a plate, but we're still not done yet, because if we're going to use this as our plate, as our first plate, uh, things are not going to look great, because this huge chunk of metal is going to just add so much weight to the gearbox. So we gotta like cut this down. So what we're gonna do is we're gonna create another sketch on top here, and I'm gonna make this top view. You just click on view orientation and click on which plane you want it to be, and we're gonna offset entities, so 0.2, and click on the pin, and we're going to select all the holes. And the reason why we're doing this is because we gotta, if we're going to, if we're going to create, if we're going to CNC this chunk of metal, right, we gotta create at least some sort of like bridge for each hole to be supported on, these circular bridges. And so that's what the offset does. It creates like these circular bridges so that these holes have some sort of support. And we're gonna offset the outer edge by a 1/4 inch. Reverse that. Bam. Okay. Now we're going to link these circular bridges. So I'm gonna use a center line and just create lines where you think bridges are necessary. And notice how I didn't create two separate lines here, because we gotta offset these at some point, and offsetting just longer lines is easier than offsetting two more lines, because it's easier to offset one line than two. So yeah, just make sure you do that. I mean, you could just follow my format if you want. That's totally fine. Alright, so I'm just gonna fast forward this until I finish creating all the bridges. Alright, so we have the bridges. So for these, I just created two lines and made these 57 degrees each. And for these, I made so these lines were originally undefined, and so I made these lines coincident with this circular midpoint, with this the circle's midpoint. Sorry, I mean the center. What am I saying? Okay. So now we gotta offset these lines. So we're gonna click on offset entities. We're gonna make it 0.1, but bidirectional, because the width of the circular offsets were 0.2, and so if we make it bidirectional, it's gonna be 0.2 in width in total. And make sure the pin is still on, because we can select on multiple entities. So just offset all of these. So the shortcut I'm using is you just left click and right click. Right? Notice how it says check mark when you right click. Makes the process a little bit faster. Right? It's all about, for me, I think it's all about speed. I don't care how interesting CADing is. I mean, it's kind of boring, I'm not gonna lie. Okay, we're done. And I just realized, like, there are these YouTube videos out there saying, oh, you gotta trim these lines. Oh, you gotta like trim this, right? So that you can see, how your bridge is gonna look like. That just takes so much time. So what we're gonna do is, okay, we have like these kind of like these like holes, kind of, right? Uh, so we gotta like fillet these somehow, because the CNC is gonna be a drill, and so the drill can't CNC like super sharp edges, right? So we gotta fillet these, and I mean, we could just use the fillet command, but for some of these, using the fillet command wouldn't work because, say, this corner, like look at this corner and this corner over here. If we're gonna make this fillet radius like, uh, so the diameter is gonna be point a quarter inch, so the radius would be 0.125, right? You know, using these two corners that are so close together, using the fillet command, it'll just make like, it would be a curve, but then it would have like some sort of sharp edge here and make another curve here, right? And so I just want to create just one curve like this. And so how we're going to do that is we're going to click on circle and we're going to find, right? Okay, look, the radius is point 12, right? And the circle doesn't even reach this bridge right here, right? So that means that even if we fillet this, it's gonna create that kind of like that sharp edge in between the two curves, right? So hold on, before I do that, hold on, delete the circle, delete it. Okay, I'm gonna recreate the circle and I'm gonna make it tangent, right? So that I won't have to, you know, make both sides tangent. I only have to make one side tangent. So I'm gonna do that for each side that I think wouldn't fit a 0.25 inch diameter circle, right? Because at school we use a quarter inch drill bit for a CNC. So yeah, tangent. I'll fast forward this because it's boring. Okay, before I fast forward, keep fast forwarding. Like, look at this one, for example. The radius is larger than 0.125, but the circle kind of like, you see how it fits, right? Like, it doesn't reach these other two circles. And so what that means is, if you use the fillet command, it wouldn't, like, there wouldn't be any problem. So just try to check which, like, what kind of, just try to check which one like fits this type of situation, which one doesn't. So yeah, okay, now I'm gonna fast forward. Okay, so I have all the circles, right? And so I'm gonna make all these equal, so just highlight all of these. Make sure you don't highlight the center of the circle because you would have to unselect that or deselect that. I don't know. And I'll just, you might have to restart selecting. Okay, I'm gonna make these equal, and I'm gonna make it 0.25 in diameter. Okay, so now I can make these tangent. Okay, so I'm gonna fast forward this. Okay, so I made everything tangent, and so here's where, uh, okay, this is, I'd say this is like the most tedious part. Uh, this time we're just like, we're filling, but we're trimming. So I mean, it's not that hard. You just need to fill it like this. Just the parts where you don't need. Like, notice how there's like this curve, right? If we filleted this, right, there would be one curve here, but then it would stop here and create like this kind of like this sharp edge, and then create another. Okay, if you guys don't understand, you don't need to because I can't speak English today. Um, just follow what I'm doing, and I'll explain to you guys uh, once I have the opportunity. Okay, now I'm done trimming. Okay, that was pretty quick. Now we could extrude cut. So features, extrude cut. If your device can't handle all this, just hide the numbers, hide the dimension numbers. That makes it a lot easier for a computer to be like, oh, hey, this looks a lot better. Okay, so once you click on cut extrude, just select all these holes. Right here. Okay, this is a problem. Okay, you see this? This line is not connected. So I'm going to exit out here and I'm going to create a line. And I'm going to highlight these two lines and make them collinear. Make collinear. Okay, it should be the same thing for the other side. Is it not? Yeah, it is. Okay. Make these collinear. Okay, now we can extrude cut. Extruded cut. Select all of these. 1, 2, 3. Okay. We're going to make it through all, right? So if I orbit here, yeah, it goes all the way through. And we're going to press done. Okay. Okay, that looks a lot better. Okay, now we're going to fill it the rest of the sharp edges. So the radius is going to be 0.125. It might put you on manual. For me, it put me on fillet expert. As long as you can select multiple, right? If there's like a pin, no, there isn't. Right? It doesn't matter. I think field expert is just easier, right? Because manual has all this stuff here. Okay, so we're just gonna, right? You see the thing here. Just select all of them. This is probably the most tedious part, but what I found helpful was you see how you can't see the corner, right? But if you hover over where you think it is, it actually does highlight. So that's what I find helpful. So yeah, I'm just gonna fast forward this until I'm done. Alright, so once you're done selecting all of this, just press the done button. And there we go, you have your first plate. Okay, so save this. I'll put this in my Gearbox folder. Plate 1. Bam. You have your first plate. Now we're going to move on to the second plate. So I'll be back once I open a new part on SOLIDWORKS. Okay, so I just opened a new part. So we're going to sketch right away. And so you can go back to plate 1 and you can click on edit sketch, right? And if you highlight all this, right, and you press Control C or Command C or whatever, go back to your part 2 and you could just Control V. I'm gonna put my mouse at the origin and bam. Okay, it's still underdefined, so I'm gonna move this over here. Okay, now it's all fully defined. Now for the second plate, I mean, we could just use the exact same plate, but we're gonna go to extra mile and cut it down some more just to save weight. So I think, so what I'm doing right now is I'm highlighting these outer lines and arcs that we don't need, right? Because for the second plate, we don't need pinion holes, we don't need motors, right? But we still need the 60 tooth gear and we still need the stand-ups, so that's why I'm keeping these two lines and this arc here. So I'm gonna right click this and delete all these things. Now I'm gonna put these pinion holes, well, you could delete them, but I'm just gonna put them in construction. put these screw holes in construction as well. If you delete them, you get like some sort of warning signal, and I don't want that to pop out because I just hate it. Okay, so we have the holes, right? But now we gotta somehow mount this to our 80/20 framing, right? And so if I open the example chassis, right? We have these uh, gussets here, these L gussets, and you can put screws here or bolts here and here, right? And so we have to make these holes into our second plate. So I already did the measurements, so let me just take out my ruler here. And so you see this bearing hole right here. We could just measure the center distance between this this bearing hole and this hole right here. Okay, so the Y distance is 2.5. So that was what I was looking for, the Y distance. So let me go back to our sketch here. The Y distance from this bearing hole right here, 2.5 up, is our where our hole needs to be. Our holes need to be. So in here there's two of them, right? So I guess it's kind of close to where the, well, this, I think Ben used the same plate for each, but for now we're just gonna, yeah, so his holes are like kind of close to this bearing hole right here. I mean, it doesn't matter how far these L gussets are from each other, as long as it supports the gearbox. So it could be like over here. As long as, I think this is like a fair. Let me just measure how far these two are. Okay, he made it 1 and 1/8. Okay, let's just make it 1 1/8 then. So I'm gonna create a line somewhere here. I'm going to make this horizontal, and I'm going to make this 2.5 inches. Right, so we now have this line right here where our holes need to go, and I'm going to create two circles, right? And these circles are going to be, hold on, no, I did the measurement wrong. Let me go back. Take out my measuring tool again. I need to measure these center distance 2 inches. Okay, make them 2 inches. Let's see what else. Oh, how large are these holes? Diameter 1/4 inch. Okay, 1/4 inch. So we're gonna make these holes 1/4 inch and 2 inches away from each other. Okay, that's easy. 2 inches. Okay, let's make these two equal. Hold on, exit smart dimension. Highlight both, make them equal. Now we can make this a 1/4 inch. They're still underdefined because they're not exactly in the middle here. So I'm going to make this circle, let's see, 1 inch away from this center line. And there we go, it's fully defined. And we're gonna keep this solid because those are actual holes. And okay, I don't like these numbers, so I'm gonna hide them. Okay. Now we have all of our holes ready. So now all we gotta do is create uh, the outer edge, right? So we're going to make this tangent, right? Make this tangent. Wait for the tangent symbol to appear. Oh, I did a center line. Okay, it needs to be solid. Okay. Tangent. Okay. If the line is still undefined, just use the tangent command. Yeah, see that one's fully defined. Okay, I'm just gonna. Is this tangent? Should be. Okay. This. Make that tangent. Oh wait, no, it was supposed to be tangent to this one. Okay. There we go. Now we need to create the arcs. Make sure the line is highlighted. Right. And this one, there's not a lot. There's not many arcs left. Right, I'm already on my last one. Yo, I'm sorry if I can't speak English. I just came back from a trip. So, okay, this one's why is it undefined? Oh. Okay. Okay, now it's defined. Okay. So we have this, now we can extrude. Make it a 1/4 inch thick. There we go. Now we sketch on the top surface here. I'm gonna change it to top view. And we're gonna offset again, 0.2. And we're just gonna repeat the steps. Specified is too big. Huh? What? Okay, just exit out. I'm gonna delete that. Okay. That's not supposed to happen. I don't know what happened. Okay, offset entities. Okay. Oh, it was on bidirectional. Okay, that's why. Okay. Okay, now we can offset. Okay, nope, I made a mistake there. Offset. Sometimes you make mistakes, man. Okay, now I'm gonna make this 0.25. Reverse. Okay, now we're gonna create the bridges to connect these circular bridges. So like here, here. Let's see. We don't need that many. So yeah. Okay, nice. Okay, this looks kind of weak right now, so I'm gonna add a little bit more. Actually, no, let me get rid of these. I'm going to, let's try to do this. Yeah. And I'll define those later. And then I can connect these with, I'll put them here. Okay. Notice how I'm adding more bridges to make it like more supported, right? If these bridges weren't here, this entire thing would just be one hole, which I do not want. Okay, now I'm gonna fully define all this. Make coincident. Why is this one fully defined? Does this one? Yeah, it's a midpoint. Yeah, delete that. If it's fully defined when you don't want it to be, click on whatever. Okay, yeah, this is gonna be coincident. Okay, there we go. Now we're gonna offset bidirectional 0.1. Select all the lines. This time, when we're filling, okay, so remember how we had to make those circles? we gotta do the same thing here. Like for example here, how are you supposed to fill it when when the line and the circle doesn't even intersect, right? So that's where the circle comes in, right? Do that, make a tangent, do that, make a tangent, right? And do the same thing like last time. Okay, this I think could fit, right? I could check that here. Yeah, the radius is already 0.16 and it fits pretty well. Okay, so this, I don't think it'll fit. Hold on, let me redo that. Yeah, that's not fitting. Okay. And I'll fast forward this until I am done. Okay, I think that's good. These two I'm not sure, but you could always delete them if they're not right. All right, so let me highlight all of these, make them equal. Then I'll make all of these 0.25, and then I'll just fast forward this. Right, it's just making all these tangent so that the circles are fully defined. I'll just fast forward this, and I'll be back. Okay, so now we just gotta trim and trim the unnecessary parts. Okay, yeah, I think that's pretty much it. Now we could just extrude cut, select all the holes. This is not considered a hole because the drill only can drill up to where this curve is, right? So I'm gonna select here, 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 bam. Okay. Make sure thin feature is off, because if thin feature is on, it makes like this weird preview thing. Now I'm gonna make this through all so that it goes through the entire plate. Cut extrude that, and use the fillet command to fillet all the other sharp edges. Right, and I'll just fast forward this and I'll be back. Alright, so I think I'm done selecting all of it. It wasn't that bad because there's less holes. So I'm gonna click on done or OK, and bam, we have our second plate. Alright, this looks pretty good. Okay, so save it. Plate 2. Save. And I mean, the assembly part, you just gotta download all the files and just do like that concentric, parallel, coincident, all that basic mating stuff. And you gotta catch your own hex shafts and spacers, but that's really easy. I think that's pretty I might make a video on it. I don't know. If I do, just watch it. If I don't, just follow the instructions. But that's it for this video on how to make the gearbox plates. And I will send an email for part 4 when all this is done. Okay, goodbye. Have a nice day.